All right, so let's have a look at 1.5 angle relationships. There's a lot of new vocabulary again that you need to notice, and I've put in the key concepts this time. So let's just have a look at the first three. The first three are adjacent angles, and adjacent means next to. Okay, so in this diagram you can see that these two angles are next to each other. They don't form any particular size or anything like that. They're not complementary or supplementary. They just have to be next to each other. Okay. A linear pair. Linear means a line, so these are two angles that make a straight line, as you can see from the diagram here. Okay, and they have to be adjacent, they have to be next to each other. And then vertical angles. This is the first one of several that we're going to come up against, with different sort of titles that as we go over, through several chapters, these are going to come up, but this is the first one. And what you can see here is what you're looking for basically is an X. They don't have to intersect at right angles, that's perpendicular. It's just two lines that intersect, and what you can see from the definition is that you've got angles 1 and 3 and 1 and 2 and 3 and 4. Okay, so they're all equal to each other. So opposite angles are equal to each other. Okay, so let's have a look at the real life. This is example 1. Here you've got 3 cheerleaders doing a formation, and what it's asking you for is 2 acute angles. And remember, from 1.4, acute means 2 angles that are less than 90 degrees. Okay, so they've given you several definitions of what they are. Okay, and don't forget you can change the letters around, so if you want MJN you can also have NJM, so but just one of them will do. Okay, and then 2 vertical two obtuse vertical angles. Okay, so you can see from the definition they've given them to you. Look at the diagram, see where they are. So this is question 1 and 2 from example 1. So we're looking at different angles and the type. So question number 1 is 2 acute vertical angles. Okay, so we need to look for an X, and we need to look for 2 angles that are opposite each other. Okay, so the only 2 you've got is this guy here and this guy here. They're the only 2 opposite angles. So we're looking at angle YVZ. Okay, and we're looking at angle WVU. Okay, and as you notice, V is the point and V is the middle letter each time. Okay, so what we need to do now is look at some more definitions. These are in key concept. The first one is complementary, the second one is supplementary. Okay, so complementary angles have a sum totaling 90 degrees. Usually they're together, like this guy, to make the right angle look, as you notice by the notation, but they don't have to be. Okay, so look at the diagram and look for 2 angles that may not be together but add together to make 90. And similarly for supplementary angles are 180 degrees. In other words, it's a straight line like a linear pair. Okay, and again, just like the complementary, most of the times they are together, but sometimes that they do not have to be. Okay, so as you can see here on this one, angles in a linear pair are supplementary, they always make 180 degrees. Angles that are complementary will always make 90 degrees. So start thinking in terms of the algebra that this book brings in. Okay, so let's have a look at example 2, and this is a typical example where you don't know anything about the angles. Okay, so as you can see from the example, they just give angle A X. Okay, so you can give it any letter, but normally, as you know, in algebra we do X. So angle B must be the 180 degrees, whatever X is. So even though you've got no angle sizes, now you can actually put things in, as you can see in an algebraic expression. Okay, and what do they tell you? So they do tell you that the difference is 18. Okay, so that's where the 18 comes from. So you solve for X. Okay, you plug it back into both of them, and then if you add them together, you've got your check. So if your check is correct, like it is in the example, you know your algebra has to be correct also. And this is question number 3. This is camera and camera lenses. So as you can see, you will have an image of the film, and the object is usually inverted and smaller. Okay, but I'm going to answer all of question 3. So 3A says what type of angles are formed by the objects and its image. So A is going to be vertical. They are vertical angles. Okay. And we did say right at the beginning when we were looking at the key concept that vertical angles are equal. So if angle 2 is 15, so is angle 1. All right, so in example 3 now we're using the algebra. And before you start, make sure you read all the statements. Okay, there's a lot of information given here that's not in the diagram. If you look at the diagram, you've got no measures, but you have got 2 different variables. You've got 2x, you've got 5x plus 6, but then you've got 4y minus 2. So you know you can't put them together at the moment, so how do we work them out separately? Well, it's this guy here. This is the one that tells you. What does it tell you? It tells you that PR, which is this guy, and SQ are perpendicular. So that means that this angle and this angle both equal 90 degrees, okay? So that's information that you need to find out from the diagram. All right, so you know that these 2 guys added together make 90 degrees. You solve for x, and then the other side, which is obviously a vertical angle to the whole side, is also equal to 90 degrees. So again, all you need to do is solve. So let's have a look at question number 4. The angle measure of 2 complementary angles are 7x plus 17 and 3x minus 20. So that means that these 2 guys must equal 90 degrees. Okay, so you've got 7x plus 17 plus 3x minus 20. Both those added together make you 90 degrees. Okay, collect the like terms together. So you've got 10x minus 3 equals 90. Put the 3 on the other side, so 10x equals 93, so x equals 9.3. And then obviously what you need to do now is plug the 9.3 into where it is. So if you put it into the 7x plus 17, so 7 times 9.3 plus 17 will give you 82.1. Okay, and then if you do the same, and this is the and, put it in, so 3 times 9.3 minus the 20 will give you 7.9. Okay, and again, just spend a few seconds. If you add these together, if you add these 2 guys together and you get 90 degrees, you know you've done your algebra correct. Okay. All right, so interpreting diagrams, what can be assumed and what cannot be assumed. Okay, so you've got to work things out that you know. You've got no angle sizes, so you can't make any too much inference. Okay, so look at what you can't do. You can't say that they're perpendicular. You can't say that the angles are congruent, and you can't say that these 4 lots of 2 segments are. Okay, but what can you say? That H is the point and things like that. So look at what you can say and what you cannot say. So when you get questions like this, so this is example 4, look for information that is on there. Okay, so if you look at what you've got here, you've got 2 lines here. They tell you that those 2 segments are congruent. So from A to B and from C to B, they are the same length. Okay, so what else have you been given? You've been given that this fact is that this is a right angle. So we know that ABF is a right angle. And other things that we're told is that this angle here and this angle here are congruent. So all of that is given to you by the notation on the diagram. So let's have a look at what you can determine, what you cannot determine from the diagram. All right, so let's have a look. The only thing that you can determine from the diagram is that EDC is a right angle. And then if you look at AED and C, it's a quadrilateral. But can you make any inference that any of the other 3, A, E or C, are right angles? No, you can't. So if you're looking at question 6, they're asking, is this angle and this angle added together complementary? There is nothing here to suggest that that's a right angle, and there is nothing in the statement there is, so you have to put no for that one. Okay, even though it appears that they are right angles, you have to say no because you've got no definite proof.